for it. So since then, Daniel Thompson has been using the developer box, and I asked him to just come in briefly this morning and share with us his experience using the developer box.
Thank you. So, I'm Daniel Thompson. I work for Linaro. And I didn't write the title of this presentation. This was given to me by somebody else. And I thought I would really do my research, make sure I got it absolutely right. So the world's first ARM developer box. Somebody beat us to it. 1987, the Acorn Archimedes. The most astonishing thing about this computer, it was a great technical achievement. If there's project managers in the room, it was perhaps an even more outstanding project management achievement. So yeah, it came with BBC Basic, an assembler built in. It ran an obscure OS named Arthur, 8 megahertz, 1 megabyte of RAM by default. Unfortunately, that's 31 years ago, we still got beaten to the second one. That was 1994, the Acorn RISC PC. It still had BBC Basic and assembler built into it. It also ran an obscure OS, slightly faster processor now. It had a modern MMU in it. This was the first ARM to get a proper MMU. It had 32 megabytes of RAM and was based on 4K pages. Then, however, there was a 24-year gap, and I've challenged people, and come and find me afterwards if you can fill in the gaps, but I think the next PC form factor was the 2018 96 boards developer box with Syncracer in it. So this has EFI shell built in, which is arguably a regression compared to BBC Basic. It runs an obscure kernel named Linux. It's got the Syncracer 24-core A53 gigahertz processors in it. It has 4 gigs of RAM, although that's in the kit. It's expandable to 64 gigs. So this is 100 times the memory of the RISC PC. And you still have to put it into 4K pages if you want 32-bit ARM containers to work or you want the NVIDIA Nouveau driver to work. The box itself could do 64K pages, no problem at all. But just think about that 100x increase in page size, in memory size, still using the same size pages. If I shall, like I say, BBC Basic is not built into the developer box, but I can offer you a simple workaround. You can apt-get a Brandy, which is a BBC dialect basic interpreter. It will give you 512K of code space for you to store your basic programs. But I'm going to add that I can't consider the EFI shell to be a regression. So please ignore all the mean things I've just said about it. One of the key things about developer box is we were able to get best-in-class kind of EFI firmware running on this box. So firmware done right. EDK2 tailored specifically for the developer box by our enterprise group. ARDS even negotiated with Richard Hughes and arranged for updates over the air via the Linux vendor firmware service. So if you are running the update daemon in your distro, it will be capable of upgrading the firmware as it goes. You don't have to worry about it. Finally, it includes a binary translator, because what we discovered is that the cards that we want to plug into C graphics it's not called the video BIOS anymore, but you know what I mean. It has x86 code needed to initialize the clocks and allow us to put menus up from the firmware. So we have a translator in there to do that. And the result is you have a box that boots and looks and feels like a PC. So it boots, and it shows a cute splash screen, and then it goes into Grub. And from Grub, you can run your ISO, you can run regular distro installers, and that is backed up by really strong distro support. So comprehensive kernel support kind of comes in the 4.16 era. So that's when we got the network drivers upstreamed. And so we can do a whole bunch of distros. I've put the ERP in gray for exactly the reasons that Kenneth was referring to. It's not really a distro, but it is a framework in which we could do a lot of testing. So you will be able to install the ERP on the developer box, well, probably forever, but we will stop promoting it after a few months when the distros start to take in the newer kernels. And that should be coming really soon. Fedora 28 is going to be based on 4.16. We sincerely hope that providing the kernel is configured with all the modules enabled, it will work out the box. It is configured with all the module enables. Likewise, Ubuntu 18.4 uses 4.15, but they agree to backport the network driver. So that has been tested as well. That's known to work. And then that's the device tree versions. In a firmware switch, you can flick over to ACPI mode, and that brings alive what you might call the John Masters dream. You can take the distros from last year. Debian Stretch is not even last year, based on a 4.9 kernel, and it will boot the developer box. At the moment, you will need some special command line options, and it turns out, we were really chuffed by this, it turns out those command line options are working around bugs. And because they're working around bugs, we will get those bug fixes back into the long-term stable kernels. And because it will get back ported, that means when we see the Debian refresh, things like Debian 9.5 come out, that will have the newer LTS backport. It's queued now for the next LTS. So we'll see that come out. CentOS is based on a slightly different kernel. It will require the same workarounds as Debian 9 at the moment. And they've done what you might call the right thing. They've got 64K pages, which is awesome, and will get lovely, wonderful performance, but unfortunately means that you will have to also blacklist the Nouveau driver if you want it to boot up. This is my developer box. It has been my privilege and joy to take one of these home from the last Connect. I have to say, Harry the Hub, this little robot, isn't there because he's cute. He's working around some board design problems with the prototypes. And my board's also had some mods, and I had my friend Lee soldering bits on and off it so that we could get it stabilized. And I'm really looking forward, because fairly soon now, the production board will be posted to my house, and I shall dig it out, and I shall plug it all in. I should also add this is a hugely oversized box so that I can engineer it. It actually doesn't fit very well on my desk. So when I get the new case, I will actually be quite pleased, because I'll get my desk back. So my box is currently upgraded to 8 gigs of RAM, 512 gig SSD, and since early November, it has been my main computer for all the work I do for Linaro. And the reason I did that was that I wanted to personally find out how we're doing in the ecosystem. We say the software is nearly there. In fact, we've learned through a lot of speakers the software is there. And that's been, roughly speaking, my experience. So this is my huge success story. This is a thing called uroot, which is a rather obscure root file system. It's a busyboxer-like, written in Go, and it has the really neat property that it's source-based. So what happens when you build a uroot is it creates you a Go compiler, copies it into the root file system, and then dumps all the source code into a source tree, and has just enough hooks in it that it will dynamically compile that source code and then cache it when you run things. And I was just really excited to see source connected so directly like that. And I fired it up, and in the afternoon, I was expecting to have a happy afternoon playing and fixing all the bugs, kind of like getting X to work in the old days. And I was actually really disappointed because it worked. It just worked. So you can go get it, you can run it, and that will create you the initramfs. And then you get this marvelous thing. You can just type kernel boot VM Linux from QEMU, and it will boot. And that's what it's doing in this video here. So that types ls. It has just dynamically compiled ls. We're now going to look to see if we can see the source. The last thing you'll see is the source coming up on the screen that has just dynamically compiled. I will concede that to get that to fit into the time I was just speaking, I have accelerated things. So for example, it does take quite a few minutes to generate the initramfs, which it was doing while I was speaking a moment ago. So don't take that as a performance reference, but it is, that was generally recorded on a developer box, and you've just seen what it can do. There was an epic fail. I have to balance it up. And it was also Go related, actually. So Go didn't add Arch64 support until 1.5. And 1.5 was also the very first Go compiler that was written in Go. And obviously, self-hosting compilers are much cooler than ones written in C, so that was awesome. But Open Embedded doesn't want to depend on the host Go compiler, because lots of people haven't installed it yet. So it works by using the host C compiler to build the C version of Go and then change it on. So I know how to fix it. You just use the host Go compiler on ARM64. But while I say I know how to fix it, I have not yet learnt how to express that in Open Embedded syntax. And yeah, if people who've used Open Embedded will recognize why I haven't done that yet. So I have the final kind of wrap up here, which is the kind of love it, hate it. And the key thing for me was that almost everything just works. You don't sit there day to day saying, oh, I wish I had my PC so I could run this tool, or at least I didn't. So that was the main take home that I picked up. Chromium is working wonderfully. It was a great joy not to cross-compile all the time, to have native KVM, to have native ARM containers. I put a blog post out this morning from the work I did with the native ARM containers. Parallel builds are fairly fast. I mean, this is a fast, it's a performance per watt machine. It's not huge single-thread performance. But parallel builds are pretty good. They outpace my 2017 laptop. I suspect my 2017 laptop, I suspect it might not keep up with an 18 laptop. So there's only a couple of things I can really say that I didn't enjoy about the experience. And the first one really surprised me, which is that you go to a website, it sniffs the browser string, it says ARM, and it says, oh, ARM do mobile, don't they? And they show you the mobile version of the website, which in the case of Google Calendar looks rubbish at full size. So yes, one of the odd hacks is you have to install an x86 browser emulator as an extension to your browser. Otherwise, you get stuck with mobile websites from time to time. The other thing, of course, like I say, this was designed to be a performance per watt machine. So when you hit desktop applications particularly, where they're single-threaded, that will reveal the limits of a 1 gigahertz A53. I mean, even that was a good thing, because one of those single-threaded applications was my mail user agent, and it meant I could go back to MUT, which has also been a regressive joy in many ways. So that's about it. I thank you all. Before I stop, I have this Monty Python foot to remind me that I need people to get on their feet right now, because I am, in many ways, a total fraud standing here. I gate crashed the Developer Box party just before the last Connect, because I was so excited about the project, I wanted to be part of it. And I've said we continually through this presentation. And so I think we need to stand up, which means all the guys at Linaro Enterprise Group who've worked on this, the Socinex development team, the Socinex landing team. So anybody, both from Socinex and Linaro and 96 boards who's been working on this product, please self-identify and stand up. If I see people not standing up, I will point you out. So yeah, get on your feet if you've had impact on the Developer Box. Please, stand up. Jazzy, you have to stand up. And that's it from me. Thank you all very, very much for your attention.
Okay, right on time. So gala tonight.